On Christmas Day 2021, humanity launched its most powerful eye yet, the James Webb Space Telescope. This isn't just another telescope, it's a time machine designed to answer the biggest questions. Where did we come from? How did the first stars ignite? Are we alone? JWST chases the faint, ancient light from the dawn of time, witnessing the birth of the first galaxies. Its gold-coated mirror spans over 21 feet, but its true power is its infrared vision, seeing wavelengths invisible to us, crucial for cosmic archaeology. Positioned a million miles from Earth at Lagrange Point 2, JWST is shielded from the Sun and Earth, allowing its instruments to cool to just above absolute zero. This extreme cold is essential to detect the faintest whispers of infrared light from the edge of the universe. The telescope itself must be colder than the signals it seeks. JWST is the ultimate observer of the cold, the dark, and the distant. Its mission, to look back to the cosmic dawn, a few 100 million years after the Big Bang, when the universe was dark and starless. JWST was built to be our eyewitness to the first light, completing a fundamental chapter in our cosmic origin story. When we look at the night sky, we're seeing the past. Light takes time to travel, so every star is a time capsule. JWST is the most powerful time machine ever built, capturing light that's traveled for over 13.5 billion years. The key is redshift. As the universe expands, light from distant galaxies is stretched into longer, redder wavelengths, infrared. Hubble could see the teenage galaxies, but JWST detects the deep cosmic base of the universe's infancy. The higher the redshift, the further back in time we look. Before JWST, the record was a galaxy at redshift 11. The universe's infancy remained hidden. By measuring redshift, astronomers build a timeline of the universe, piecing together its history from the Big Bang to now. Every new, high redshift galaxy is like finding a baby photo in the universe's family album. JWST was designed to find those very first baby pictures. It's our window into the universe's earliest moments. In May 2025, JWST shattered expectations by discovering MoM z14, a galaxy so distant and ancient it rewrote our cosmic timeline. Using spectroscopy, scientists confirmed its redshift Z equal sign 14.44. That means its light began its journey when the universe was just 280 million years old. To put it in perspective, if the universe's history were a year, MoM z14 formed on January 8th, the Milky Way wouldn't appear until March. MoM z14 is the earliest and most distant galaxy ever seen, beating the previous record by 20 million years, a huge leap at this early epoch. Finding such a bright, substantial galaxy so soon is like discovering a fully grown oak tree where you just planted acorns. Its existence suggests the cosmic dawn was a sudden, brilliant explosion of light, not a gentle sunrise. The early universe was far more active and crowded than we thought. MoM z14 is a signpost pointing toward a new, unknown chapter of cosmic history. What does MoM z14 look like? Through JWST, it's a cosmic toddler, small, energetic, and growing fast. Just 500 light-years across, it's a speck compared to our Milky Way, yet it contains the mass of 100 million suns. MoM z14 is a stellar factory, forming new stars at a blistering rate, about 13 times the mass of our Sun per year. For its size and age, that's extraordinary. Our Milky Way forms only 1 or 2 stars per year. This rapid starbirth makes MoM z14 so luminous, visible across 13.5 billion light-years. Its young, massive stars blast away surrounding hydrogen, creating a transparent bubble in the cosmic fog. Finding such a large ionized bubble so early hints that ionization was driven by hyperactive galaxies like MoM z14. It's a compact, dense, and brilliantly luminous pioneer, one of the first significant structures to emerge from the cosmic dark ages. MoM z14 offers a direct window into the chaotic, creative processes that shaped our universe. It represents a crucial, previously unseen phase of galactic evolution. The most startling revelation from MoM z14 wasn't its age or brightness, but its chemistry. The Big Bang made only hydrogen, helium, and a trace of lithium. Heavier elements, carbon, oxygen, nitrogen, were forged later in stars. The early universe should have been chemically pristine, but JWST's spectrographs found MoM z14 already rich in heavy elements. The abundance of nitrogen in particular was a shock. Usually produced by longer-lived stars, it suggested rapid chemical enrichment. At least one, maybe several generations of massive stars had already lived and died before MoM Z14 became visible. This discovery upends our timeline of cosmic chemistry. The universe built the elements of life far earlier and faster than we imagined. Stellar factories were operating at maximum capacity from the very beginning. The conditions for forming complex structures and maybe even planets were in place much sooner than we thought. The universe wasted no time moving beyond its simple beginnings. MoM Z14 shows us the cosmos was in a hurry to create. MoM Z14 isn't just a new detail. It forces us to rewrite the cosmic storybook. The standard model, Lambda CDM, predicted slow bottom-up galaxy formation, small clumps merging over hundreds of millions of years. But MoM Z14 and other early massive galaxies are too big, bright, and mature to fit this leisurely timeline. JWST is finding these galaxies are far more common than predicted, by a factor of 100 or more. The early universe was a bustling metropolis, not a quiet nursery. This suggests a fast track for galaxy growth. Perhaps massive clouds of gas collapsed directly, bypassing the slow merger phase. Did the first stars form earlier, or was dark matter different than we thought? These are the questions now keeping cosmologists up at night. MoM Z14's discovery sends ripples through all of cosmology, challenging our understanding of reionization and dark matter. The process of reionization, when the universe became transparent, may have started earlier and been driven by powerhouse galaxies like MoM Z14. If the early universe was filled with hundreds more bright galaxies than we thought, reionization could have been rapid and patchy. The existence of massive galaxies so early hints that dark matter might not be as cold or simple as we assumed. Alternative theories, like warm or fuzzy dark matter, are now being explored. Even our measurements of cosmic expansion may need recalibration if early star formation was faster than expected. MoM Z14 is a perfect example of how one discovery can force us to reevaluate the entire cosmic web of ideas. The universe is more interconnected and surprising than we ever imagined. A MoM Z14 is just the beginning. JWST is pushing the boundary of the known universe further back in time. Astronomers believe even more distant galaxies await discovery, perhaps at redshifts of 15, 16 or higher. The next quest, find the first generation of stars, population 3, massive, short-lived, and forged from pure hydrogen and helium. JWST may spot their collective glow or chemical fingerprints in even earlier galaxies. Gravitational lensing, using massive galaxy clusters as cosmic magnifying glasses, will help us see even fainter, more distant objects. Each new discovery refines our theories of rapid galaxy formation. Future observatories like ALMA will dissect these early galaxies in detail, mapping their gas, stars, and chemistry. We're on the edge of a new era, asking questions about the very first objects to shine. The story of creation is being written, and JWST is holding the pen. Science is a journey of humility. Every new discovery reminds us the universe is richer and more complex than our theories. MoM Z14 is a profound reminder. The universe isn't obligated to meet our expectations. When we look at its light, we see the ancestral glow of our own cosmic family tree. The elements forged there would one day form planets, life, and us. Each early galaxy is a missing page from our origin story, binding us to the farthest reaches of space and time. JWST will keep searching, finding even older and stranger galaxies, each a new piece of the puzzle. We're living in a golden age of astronomy, with answers to ancient questions finally within reach. The greatest gift of discoveries like MoM Z14 is the sense of wonder they inspire. They remind us the universe is still largely unknown, with mysteries in every patch of dark sky. Thanks to JWST, the cosmos is speaking, and we're finally beginning to understand its language. The story of the universe has just become a whole lot more interesting.